In this lecture and in the next few lectures, I'd like to talk about WPA Enterprise, what it is, how it works, and how to hack it. Now, all the networks that we've seen so far in this course and in my other hacking courses, whether they're WPA or WPA2 networks, all of them were using a form of authentication called PSK. PSK stands for pre-shared key, and what we mean by that is there is one shared key that any device that wants to connect to the network can use, and they'll get access to the network. So there is one key in the network. That key is shared between all the clients, all the devices that want to connect to the network, and if you have that key, then you can authenticate and connect to the network. Now, because this is a very simple concept, the router manages the authentication in this case because we only have one key. So whenever a client wants to connect to the network, they have to give that one specific key, and if that key is correct, the router will allow the client to access the network or the internet. If not, then they'll just refuse them and not even give them an IP address. Now, WPA Enterprise is another form of authentication. So we have PSK, which is pre-shared key authentication, and we have another form of authentication called WPA Enterprise. Now, as the name suggests, it's designed for bigger and larger networks. It's usually used in large organizations such as big companies, universities, and so on. The idea behind this is each user that wants to connect to the network needs to have their own username and their own password. So there is no shared key. Each client has to have their own key to connect to the network. Now, this is actually a more secure implementation, and it has a lot of advantages. First of all, it's more secure because each user will have a unique key, so their traffic will also be encrypted using this unique key. And it's more practical because if you want to deny a certain user from connecting, you won't have to change the one password. You'll just have to remove their password from the authentication server. Now, because of this idea and this implementation, the router cannot handle this, and we usually use a central server for authentication. Now, the central server is very handy because we can add users and prevent users from connecting to the network without having to change the password for the whole network. So when using a pre-shared key, if we wanted to prevent a certain user, or if we thought that our password got stolen, then we have to change the password, and then we have to give the new password to all of the users that we want to allow to connect to the network. In the WPA Enterprise case, we don't have to do that if we think a certain password is stolen, or if we want to prevent a certain user from connecting, then we can just modify our central server, the radius server, and remove the password that we don't want to allow on our network. Now, WPA Enterprise is also considered to be more secure because, like I said, each user gets their own key and their traffic is encrypted using their own unique key, whereas in PSK, in the pre-shared key authentication, all the traffic through the network will be encrypted using the one single shared key. So regardless of the user, they'll all be using the same exact key. So right here I have a diagram of the way WPA Enterprise usually configured. Now, the access point will not be handling authentication like I said. So the client is going to use some sort of authentication, usually a username and a password. It's going to send it to the access point. The access point will not do any form of verification. It will literally just forward that to the radius server. The radius server is the brain, or is the entity that decides whether this form of authentication is correct or not. If the username and password are correct, it's going to tell the access point, okay, these are correct, allow this device to access the resource, whether it's the internet or the network. So the access point is going to assign an IP address to this computer and allow it to access the network. Therefore, when we want to add new users or prevent users from connecting, all we have to do is just modify our server here and remove the users that we don't want them to connect. Now WPA Enterprise uses an authentication protocol called EAP, but there are other implementations that you might face like EAP Fast, LEAP, and TLS. Now I'm just trying to give you a basic understanding of what we mean by WPA Enterprise and how it works. And in the next lecture, we're going to discuss how we can hack this and gain access to networks that use this form of authentication. Okay, so far we know WPA Enterprise is an authentication method that can be used with WPA or WPA2 networks. So it uses encryption, and in it, each user have to use their own unique username and password to authenticate and connect to the network. And we said all of this is managed using a radius or a central server. Now let me show you an example of a network that uses WPA Enterprise just so you get an idea of how it works. So if I go to Wi-Fi here, you'll see that I have a network here called company network. If I try to connect to this, you'll see it won't even try to establish a connection. The first thing that it's going to do is it's going to ask me to enter a username and a password. Now the same happens here if I go to an OS X machine. So if I just connect to it in here, you'll see that I'm going to be asked for a username and a password. The only difference is the login box looks a little bit different. Now if you think of the idea, it's very similar to what happens with captive portals. It's just implemented in a much more secure manner. As shown before, captive portals also ask their users to enter a username and a password, and if they're correct, they'll allow them to use the password. The only difference is captive portals are open networks. They do not use any encryption. Therefore, we were able to go in monitor mode, sniff all the data, and if a user authenticates, we'll be able to capture their username and password. Not only that, because it's an open network, we were able to connect, run an ARP spoofing attack, redirect the flow of packets through our computer, and that way we were able to read the usernames and passwords as well. Now both of these methods will not work with WPA Enterprise. First, because like I said, it uses encryption. Therefore, even if we go in monitor mode and sniff data, the data is going to be encrypted, and because we don't have the key, then we won't be able to find the passwords that's entered by the users. The other problem, because as we've seen, we can't connect to the network without having a key. Therefore, we can't run an ARP spoofing attack because we can only do that attack after we connect to the network. Therefore, both of these methods are useless against WPA Enterprise, and the only way to attack it is using an evil twin attack. Now there are two ways to do that. You can create a traditional evil AP just like I showed you before. The only thing is you want to make sure that the login page that you automatically display to the person when they connect looks like a login box, because with captive portals we've seen by default users log in using a page, using a HTML web page. With this we've seen that in Windows you have to log in here. In OS X, you get a box, a login box like this one. So you're gonna have to fool your target to think the HTML page is what they usually use. With OS X, this might be easier because like we've seen with captive portals, OS X was still showing the HTML page inside the window, so you'll just have to style your fake login page a little bit to make it look like a system login box. When it comes to Windows, it's going to be a little bit more challenging because as we see, Windows automatically opens the login page in the default web browser. So the user will feel that there is something suspicious in there. Another problem, you'll see in here, you can see that it says secured. Also in OS X, if you look at the network name here on the top, you'll see there's a lock beside it. Now, as you remember, when we were creating our fake access point, it has to be an open network so they can connect to it and then authenticate. Therefore, the traditional method of doing this is good, but it might not fool all users. The advantage of this method is that the user is going to send the password through the HTML form, which is sent in our fake login page, and therefore it'll be very easy for us to capture it and read it, as I showed you before. Now, executing this method is identical to targeting a captive portal. So I covered all of these steps before in details, and therefore I'm not going to be covering it in here. I'm just simply mentioning that you can actually use that method to target this type of networks. What I'm going to show you though, the next method, which is a little bit more advanced. Now this is also an evil twin attack. We'll be also creating a fake access point, but we'll actually configure this access point to use WPA Enterprise. So when the user connect to it, they'll get a login box, a system login box. So in Windows, they'll get something like this. In OS X, they'll get something like this. But once they put the password, obviously the password will be sent to us because we will be running the Radius server, the central authentication server that I was talking about. And that way, it'll be much easier to fool your target to connect to your network, because these networks are usually used in large enterprises. So again, like I said, similar to fake access points, the users are used to connect to a number of routers and are used to see a number of routers around them. So what we'll be doing is we'll be de-authenticating them from their router, and we'll be creating a router that looks identical to the router. It's going to have the same name. It's going to be using the exact same configuration. So they'll be logging in exactly the same way that they usually log in. Therefore, they're not going to be suspicious of the whole process. The only problem with this method is the data sent to us, or the password, is going to be encrypted. And therefore, we'll actually have to use a word list attack to try and crack this password. Now in the next lectures, I'm going to talk in details about how to execute this attack, how to create a fake access point with WPA Enterprise, and I'll also be discussing why the password is going to be encrypted and how to decrypt it. Okay, now that we know the methods that we can use to gain access to WPA Enterprise networks, in this lecture, I want to show you the more advanced method, the one where we create a fake WPA Enterprise network. So the first method, like I said, it just uses a traditional fake access point, and I covered this before in details. I covered each aspect of running this attack in details so that you can adapt it to any scenario. And this is a perfect example where you can't use tools like Fluxion and Wi-Fi Fisher, and you'll have to do it manually, and I covered how to do it manually before. That's why I'm going to be covering the more advanced method in this lecture. So I'm going to go to Kali, and the first thing that I'm going to do is I'll need to install a modified version of host APD. So we used host APD to generate the normal fake access point. Now there is a modified version called host APD WPE, and that version of host APD is designed to run a fake access point with WPA Enterprise with free Radius server. So first of all, I'm going to have to update my sources. So I'm going to do apt-get update. Now that my sources are updated, I'm going to do apt-get install, followed by the program that I want to install, which is called host APD WPE. So we always use apt-get. We're just telling it to install, and the package name or the program name, it's called host APD WPE. I'm going to hit enter, and that will automatically download the program, all the needed packages, and configure it for me. Okay, now that's all done. So I'm going to clear the screen. And the next thing that we want to do is very similar to what we used to do with host APD. We want to modify its configuration. So to do that, we're going to do leafpad, which is my text editor. And I'm going to put the location of the configuration file. And that's stored in etc host APD WPE. And again, host apdwpe.conf. So we're doing leafpad, which is our text editor, and then we're giving it the location of the configuration file for host apdwpe. I'm going to hit enter. And the main things that you want to make sure are set correctly is, first of all, the interface. This is your wireless adapter. So in my case, it's actually called LAN 0. If you don't know what it's called, you have to do ifconfig, as you should know by now, and then you can get the name of it. The next thing that I want to modify is the SSID. This is the name of the fake access point, and it's set by default to be called host APD WPE. Now, my target is called company network, so I'm going to call this company network as well, because as you know, this is an evil twin attack, so you want the fake access point to have the exact same name as the target access point. So we're calling it company network. You can also modify the channel in here if you want, but I'm going to keep that the same. And I'm actually going to leave everything else here the same. Now if you scroll down, you'll actually see after this point, and it says it here in the comment, everything that comes after here is literally just a normal host APD configuration. So like I said, this is just a modified version of host APD, which is modified so that it can use WPA Enterprise with free radius server. So I'm gonna save this, Ctrl S, and quit it, Ctrl Q. Okay, now we're done. We're ready to run the attack. But before we do that, like we did with host APD, we have to stop the network manager because it's managing my wireless interface, and if it stays running, it won't let me use it to create a fake access point. So I'm going to do service, network manager, stop. This will stop the network manager for me, and now I can run the fake access point with WPA Enterprise. To do that, we're going to do host APD WPE, followed by the location of the configuration file, which is in etc host APD WPE, host APD WPE.conf. So this command is actually very similar to the host APD command that we used to use. You just put the name of the tool, followed by the location of the configuration file. I'm gonna hit enter. And as you can see right now, it's telling me that the network is working. It's broadcasting under the name company network. And now you can just go ahead and run a deauthentication attack. As I showed you before, you can deauthenticate all clients or some clients, again, as shown before. Clients will not be able to access their network. They won't be able to use their network. So they'll think, oh, maybe I can just connect to the other company network. So let's go to a Windows machine and see what we have. So I have my company network in here. I'm going to connect to it. And I'm going to put my username as Zaid and my password as 1234 ABCD. I'm going to connect. Now this is just a warning saying that if you expect to see this network, then connect to it, otherwise don't. Most people will just connect to it because, like I said, WPA Enterprise is usually used in large organizations, so people are used to see a number of routers and connecting to a number of routers. And if you run a deauthentication attack and they can't connect to their own router, then there is a very high chance of them trying to connect to the other router or to the other access point that has the exact same name that they're used to. Therefore, I'm going to click on connect. Now it's saying it can't connect to this network because I actually used wrong username and password anyway. But if we go to the Kali machine, you'll see that we captured the username, we captured the challenge, and we captured the response. Now I know this is not the password that I put, so you still can't see 1234 ABCD, and that's because the password is encrypted. That's why I said the basic evil twin method that we showed before has an advantage over this method because the password will be sent in plain text over HTTP. The problem with that method was the login screen wasn't very convincing. With this method, you'll get a proper system login box because we are implementing a proper WPA Enterprise network, so there's nothing fake about it. The only problem is, because this is a proper WPA Enterprise network, the password will be sent based on the authentication method used, which is a challenge response method where the router sends a challenge and then the client sends a response based on that. Now in the next lecture I'm going to talk more about this, and I'm going to show you how to crack the response and get the key for the network. But for now, our attack is done. We managed to capture the username and the hash for that password, and in the next lecture I'm going to show you how to crack that password. Okay, now in the last video, when the user logged into our network and put the username and password, we only captured the username. We didn't get the password, but instead we got something called the challenge, and we also got a response. Now the reason for this is because, like I said, the network that we created, the fake network that we created, uses a proper WPA Enterprise authentication. Therefore, when a user tries to connect to that network and authenticate, they'll use what's known as a challenge response authentication. So in order to understand what we mean by a challenge and a response here, let's have a look on this very simple diagram that I made. I'm trying to keep this as simple as possible so that we don't get carried away talking about algorithms, encryption and all of that, because that on its own needs a full course. So basically what happens when a client tries to connect to a network that uses WPA Enterprise, we said this is managed through a radius server. So what happens is the client sends a request saying, I want to connect. The server says, okay, no problem, solve this challenge for me. So it gives the client a challenge to solve, and this is what you see in here. So we can see this is the challenge that the server that we are running, because in this case we have a fake access point. So that's the challenge that the server sent to the client to solve. The client goes ahead and solves the challenge. It solves it by encrypting the challenge using the password that you put. So basically the password that you put in the login box will never be sent to the server. What happens is that password is used in a certain manner so that it converts this challenge, encrypts it, and converts it into a response that the radius server will be able to understand and verify if the password was correct. So you say, I want to connect, server says no problem, solve the challenge for me. Challenge is solved based on the password that you enter, and it's sent to the radius server. Now when we look at this, we can see the challenge and the response sent. Now this challenge is encrypted using Net NTLM version 1. Now this is a strong encryption, and for us we can't actually just encrypt it based on the response on its own. So we actually need to use the response and the challenge, and we'll also need to run a dictionary attack. The way this dictionary attack is gonna work is it's gonna go over a list of a lot of words. It's gonna take each one of these words. It's gonna try to create a response based on these words and compare it to this response. If the response generated using the word in the word list is correct, then the word used to generate that response is the password. Otherwise, it will try the next word. So again, the way the word list attack is going to work is it's going to go through a list of a lot of passwords that we're going to give to the program. It's going to take each one of these passwords. It's going to apply the formula and try to solve the challenge to generate a response. The response generated is going to be compared to this response right here. If the response is valid, then the password used to generate it is the valid password. Otherwise, it's going to try the next password. Now there is a number of tools that can run a dictionary attack against Net NTLM hashes. The one that I want to use is called ASL EAP. Now you can use Hashcat and John for that, but this tool is just simpler, and that's why I'm going to go for it. Now before using this tool, let's have a look on its help menu. So we're going to do ASL EAP help. So you can see the options here are very simple, and you can see the usage is you literally just type in the tool name followed by the options. So first of all, let's type in the name of the tool, which is ASL EAP. Then we want to use the -C option to give the challenge. So we have the challenge in here. I'm going to copy it, and I'm going to do -C and put the challenge. Next option that I want to use is the response, which is -R in here. So again, I'm going to do $R, and then I'm going to put the response that we got, which is this one in here. So I'm just going to copy it and paste it. Finally, we want to specify a dictionary to use to crack this hash, and to do that we're going to do -W. And I've already created a dictionary using Crunch, so you can create your own dictionary or download the dictionary online. The dictionary that I have is stored in root, and it's called word list. And that's it. So the command is going to be ASL EAP. We're doing -C to give the challenge, followed by -R to give the response, and finally we're given the word list. So again, what this tool gonna do is it's gonna open this word list, it's gonna go on it word by word, generate a response based on this challenge, and compare the response with this response right here. If the response generated from the word in the word list is valid, then that word is the password. Otherwise, it's gonna try the next word. So I'm gonna hit enter and let this run until it gets me the password. And as you can see, this was quite fast, and it got me the password right here. The password is 1234 ABCD, and that's actually the password that I used. So right now we have the username, which is Zaid, and the password, which is 1234 ABCD.